Okay, so we are live. So today we have part 2 of our Intro to Data Science workshop, and we have Harkirat Singh here back again. And this time we'll go a little bit deeper into the subjects we started discussing and working on yesterday. So whenever you're ready, you can share your screen.
Okay, sure, Emma. Um, all right. I hope everyone can see my screen. Okay, so first I will do a quick recap what we discussed yesterday. So in case anyone was not present in yesterday's session, so they can see what we discussed yesterday. So we were just discussed the basic data types of the Python. So and we also discussed that in Python you don't have to explicitly tell to the Python language that what data type is, I mean, for any variable, you don't have to explicitly define the data type. Python will take care of itself. So, for example, if I'm passing value 5, and if I type and if I check for its type, it returns a value integer. So Python knows that it's an integer. We don't have to tell Python. The same case is with a string, and with the string you can perform some basic operation, like you can, these are the methods like upper, lower, and replace. So these are like inbuilt methods in the Python language, and you can convert, if you using these methods you can transform a string, like you can transform into uppercase string or the lowercase string, and you can replace the value. For example, here we are replacing hello with hi, and we can even split a string. We are splitting one string into two multiple strings. So hello Hacktable is now converted into two separate strings. One string is hello, other string is Hacktable. So like that. And you can split it based on based on the space. So if you don't define anything, so it will automatically split a string based on the space. However, if you want to split it by some alphabet, or any digit or character, you can give that character here, and it will split based on that character. So for example, H is not showing here, only the allo and actable string is showing. Similarly, you can search any string based on the index position. So for example, I want to see uh, on the index position 6 what value is there. So index position 6 is this H. So this is index. So index always start from 0. So this H is on 0 position. So 0, 1, 2, 3, 4, and then this space takes the 5th position, and then H, this is on the 6th position. So like that. And then you can combine or concatenate two strings. For example, in this string the value is like this Harkirat, and if I combine these strings using the plus operator, and you can see this string is concatenated. Hello Hacktable, this is Harkirat. You can also make it, you can also concatenate it using period and space, so that it is easier to read. Hello Hacktable, period, and then space, and then this is Harkirat. So this is how we can perform operations on a string. Then we discuss the next data type on the list. So list is another data type. So if you want a sequence of value, the sequence of items, so you can store them in the list. So for example, apple, banana, orange. So these are like sequence of items. So I'm storing in a list. And if you check what is the type of this variable, so this variable is returning, so it is returning the list. So basically Python knows that it's a list. You don't have to tell Python that it's a list. Python knows on its own. So there are some operations that you can perform on list. There are methods available. So for example, append method, it will append this value avocado, uh, and if you see the list again, you see the avocado is inserted. So this is how you can impute or insert a value using the append method in an existing list. And for example, but if you want to uh, append a list inside a list, you can do that as well. So it will show as a list inside a list. However, if you just want the contents of the list and you don't want these square brackets inside the list, so you can use another method, which is extend. So there's a small difference between append and extend method. And if you want to remove any contents, so for example, if I want to remove this small list containing strawberry and grapes, so and using the remove method, if you see, you only see these contents without any list inside a list. So the contents have been removed, okay, using the remove method. However, this remove method can't remove any item using the index position. So for example, if I want to remove any item using the index position, so index position is like 0, 1, 2, 3, 4. So it won't be able to remove. So for that, if you want to make your life easier, you can use a pop method. So pop method, it basically removes it can use that index position. So it is telling you that it has removed that strawberry. And if you check the content of the list again, you will see that the strawberry has been removed. Okay. Similarly, in the list, you can do the slicing. So this is called the slicing. Slicing basically means you just want to see only a slice of a list. You don't want to see all contents of the list. So for example, uh, this is the whole list, and but I just want to see the first three contents. So you can give the index position. So starting from the 0, because you're starting from you want to see the first uh, first three items. So it will start. So 0 is always, you always start the index position from the 0. And so it will be like 0, 1, 2, 3, 4, like that. So for the first three will be 0, 1, and 2. So they will be like apple, banana, and orange. Also note that whatever the value you specify here as a last index position, that will not be included. So for example, the third position. So this third position refers to avocado, 0, 1, 2, 3. So we are not including that avocado. So always keep that in mind. So here as well, here it will showing the 0 and 1, not the 2, apple and banana. You can also you can also check the contents of the list from the opposite end. So for example, if I want to check the second last item, so second last item we will be avocado, so it shows avocado. All right. And if I want to check the last item, so last item will be like -1. So let me run this again. -1 is like so 1 second. Oh, okay, because it is because the contents of the list has been changed. So let me rerun the cells again. 1 minute. Yeah. So now it's working. So for example, so the last item is a grapes. So using -1, it is showing the grapes. So the opposite end, the index works like -1, -2, -3, -4, -5, like that. But from the normal end, it will start with a 0. From the opposite end, the index starts with -1, right? Similarly, if you want to check the last, uh, uh, the second last value and the third last value, so it will show like -3 and -2. So -3 is like orange, -2 is avocado. Again, this index is not included, the second index position. So -1 is a grape, so that's not included. All right. And then we can perform the sort operation. So for example, with the sort, we can sort alphabetically. So all the items, so for example, items with the alphabet A, they come first, then with B they come second, and then G, and then O. You can also sort in a reverse way, like the orange will come first, grapes, and then banana, and then avocado, and then apple. So with the reverse, if you do the sort, so it will showing the the sequence in this fashion: orange, grapes, banana, avocado, and apple. Then the next my next item we discussed was the grocery items. Next data type was a dictionary. So in dictionary we store the values as a key value pair. So for example, fruits is a key, vegetables is a key, dairy is a key, and for each key I'm storing these values: orange, grapes, banana. And then for vegetable key I'm storing the values as cabbage, spinach, and potato. All right. And so the benefit of dictionary is that you can categorize the value. So for example, these values are categorized. Uh, so these values, orange, grapes, and banana, they are categorized as fruits. And these values like cabbage, spinach, potato, they are categorized as vegetables. And so this is possible in dictionary, but it is not possible in list. So that's the benefit of dictionary. And you can, if you just want to see the keys, you can use the keys method. If you just want to see the values, you can see the values method. And with the dictionary, if you just want to see the contents of one particular key, you can slice it using the key value. For example, there is grocery items with the dairy, and it will show the contents or the values only for the dairy key. And so like that. All right. So again, if you want to remove any content uh, of any dictionary, so you can use the pop method, and you can use the dairy key. So here in dictionary, the key values, they act like an index. So here in pop method, it's acting like an index, and it will remove the contents of this method, of this key. So in the grocery item, if you check the contents again, you only see the keys, fruits, vegetable, and beverages, but you don't see dairy anymore. All right. And then we discussed the Numpy library. So Numpy is a library, pre-written by some other Python developers. So it is making your life easier. So the benefit of this is that you can store the values in an array, and you can perform the computations even faster. And you can perform the computations like numerical computations very faster. Like if you want to check the mean or the average, or if you want to check the standard deviation. So those kind of numerical computation you can easily perform. And also you can store the values in a numpy array in a two-dimensional way. So it is showing that in a matrix. So this if you see, this is a matrix like structure. And the benefit of this is that if you want to perform operations only on the row wise operation, uh, like this row, if you want to perform operation on this row, or you can also perform operations on just one column, like this 20, 50, and 80 in the second column. So you can do a row wise or column wise operation. So that's the benefit. Another benefit is that you can perform mathematical operations on a whole array or a whole matrix altogether. So if I multiply it with the three, this matrix, this array, all the values, they get multiplied by 3. So example, 10 gets multiplied by 3, shows 30. The 50 values get multiplied by 3, showing 150, all the values. However, if you were using a Python list instead of numpy array, you had to multiply it. You first have to do the search. You have to find and extract every value one by one and then multiply. But here you don't have to extract or search every item one by one. You can just multiply it, all together. And also, if you can subtract or you can add two matrix or two arrays. So for example, here I'm doing a subtraction, and all the values with respect to their index value, like with their matching index value, they get subtracted. For example, 10 gets subtracted from 30, it shows 20. 90 gets subtracted from 270, it shows 180, like that. All right. Similarly, you can easily calculate the mean. So the mean of that array is 100, and the standard deviation STD method is there. You can calculate standard deviation. So this value will show. And but the only problem with this numpy array is that all the values are stored with the same class. So even if you store different values of with the different data types, For example, mango, this is a string. The value 1 is an integer, value true is a boolean. In a Python list, they show their correct data type like string, integer, and then boolean. However, in the NumPy array, if you store these values, all values are shown as the same class string. And because NumPy automatically converts them to same class. And the reason NumPy does that so that you can perform the same operation in all those in the whole NumPy array. If all the values are showing that different data type, then you won't be able to perform those numerical computations, right? That's why they are converted to the same class. So you can convert the shape of an array or NumPy array. So for example, this has 3 rows and 3 columns. So basically the total 9 values are there. You can reshape it as 1 row and 9 columns or 9 rows and 1 column, right? So you can reshape the array however you like, and then you can perform uh, the uh, the logical operation. For example, if I just want to filter the values which are greater than 70. So for example, here in array underscore double, which values are greater than 70? For example, this is greater than 70 are these rows, 80 starting from 80 and up to 180. So 20, 40, 60 are excluded. So for 20, 40, 60, they are shown as a false. All other values are shown as true. However, you can filter them using this Boolean index. So whatever the values are greater than 70, so at the index, it will show all those values. So whatever the values are true, they will be shown. The false values, values mapping to false, they won't be showing. Okay, and you can use the AND operator. So for example, if you want to combine two logical operations, you can do that. So for example, here I want to filter which values are greater than 70 and which are less than 150. So it combines these two operations and it shows, okay, these are greater than 70 as well as less than 150, right? And then after NumPy, we discussed the Panda library. So Pandas is built on the top of NumPy library. So basically, you can structure it in a tabular fashion, in a tabular way, in any NumPy array. So for example, you can give the name to the every column, and it will show their values in a nice structural, nice tabular format. And we call it and we call this structure as a data frame. Okay, so you can convert any NumPy array into this data frame, and you can pass the list of columns in this columns parameter, and you can and you can search. The benefit of the name of the column is that if you want to search the contents of the column, you can just specify the column name. However, you also have to specify the rows. So it like rows comma column. So the column here, it means all of the rows. Okay, all of the rows. So it's showing all the rows 40, 100, and 160 for the second column. However, if you want to search, and if you just with the index, so you can give that index position like second row and second column. And for example, the second row, the row at the second index position and the row at the second, the column at the second index position. Okay, it's not the second row, it's the row at second index. So basically, it's a third row. So for example, because it starts with the 0, 0, 1, and 2. So the second index is basically the third row. Okay, and the second index in the column is the third column. So third row and third column, it maps to the value 180. So it's showing the value 180. Okay. So this is what we discussed about the Python. And then We also discussed about the machine learning. What is machine learning? Okay, so machine learning is basically is a field of study that gives the computers the ability to learn without being explicitly programmed. So basically, you don't have to. So once any algorithm is trained, you don't have to program it again to make the predictions. So algorithm can make the prediction on its own after it is trained. Okay. So for example, so how it learns that how it machine algorithms they learn from the data. So for example, here uh, we pass the data. So here the data is nothing but the pictures. So pictures is the input data to the machine learning algorithm, and we pass the labels. So like so for example, this is a car, this is a bus, and this is a cyclist. And after we pass this data to the machine learning algorithm, the machine learning algorithm going forward can figure out on its own that if it's a car, if it's a bus, if they are cyclist or not. So you don't have to program it to make further predictions. This is how machine learning algorithms they learn from the data. Okay. Then we discussed that machine learning algorithms they have three types. One is a supervised learning, other is unsupervised, and the third is reinforcement learning. Semi-supervised learning is also there, but it's not that much used. These are the like three main categories. So the difference between these categories that in supervised learning we pass the data with the labels. Okay, so for example, we are passing the data with the labels. So for example, we are telling the algorithm that this is a bus, this is a car, this is a cyclist. But in unsupervised learning, what will happen? We won't be passing the labels. Okay, so in that case, what machine learning algorithm will do in unsupervised, it will make a cluster of the related pictures. So, for example, all the buses will be in a one cluster. They will be categorized in one cluster, and all the cars will be categorized in a separate cluster, and all the cyclists will be it will have their own separate cluster. So, for example, so this is how one cluster is of one item, another cluster of another item. And if you see how these news items are grouped together, and there's a one cluster of related news. So for example, in this cluster, all the related news of oil spill are shown. And in this cluster, all the news of stocks and finance or recession, they are clubbed together. And here all the news related to the politics of the White House, they are clubbed together. So this is how the clustering or the unsupervised algorithm works. So if you see, this cluster is taking the news from three different sources: CNN, the Guardian website, and the source. Then it has made a group or a cluster of the related or the similar news. Okay. Then comes the third machine learning algorithm, which is the reinforcement learning. So here, what happens? The robots is a perfect example of the reinforcement learning. So how the robots learn? Basically, we use the reward and the punishment mechanism. So if a robot scores a goal, then we reward it. And if a robot passes a ball to its own team member, then we again reward it. However, if a robot passes the ball to its opponent team, then we punish it. Or if a robot scores its own goal, then again we will punish it. So the goal of the robot will be to increase its reward, and whenever it gets punished, it will keep that thing in its memory that he doesn't he should not do the same mistake. And based on the reward, the robot will keep on learning. Okay, so So how we can reward? Basically, we can increase some score, or increase the value of a variable, and as the value of the as the score rises, so that robot will keep on performing those operations, which gives him the more reward. Okay, it's just like how we train the dogs or small puppies. We give them a treat when they perform certain activities. So this is how we train them. Same thing we do with the robots, and it's called reinforcement learning, right? So now let's move to the case study. So this case study we will be doing for the predicting the house. So this is supervised learning and not the unsupervised. The reason it is supervised because we are passing the label which we want to predict the price. So let's say we have data of 100,000 homes, and out of 100,000 homes, let's say 70,000 homes, we have the price information available. But for the remaining 30,000 homes, we don't have the price, and we have to predict. So because the 70,000 homes, they have the price data available, which is a target variable. So we call it a supervised because we have the label available, the price, at least for some of the data. Okay. And this is called the regression. So in the supervised learning, there are two types, regression and classification. So regression is that where we are predicting something numeric value, the continuous numeric value. And the classification is that where we are predicting something discrete value. So for example, what is the temperature going to be tomorrow? So we are going to predict, let's say it's 84 degrees Celsius. So it's a continuous numeric value. It can be 83, it can be 85, it can be 84. And but in the classification, it will be a discrete value. Either it is a cold or it's a hot. You know, all the temperatures less than 50 degree, uh, they are categorized as cold, and all the temperatures more than 50, they are categorized as hot. So in classification, we just have two discrete values, two discrete outcomes. But in regression, we can have any number of outcome, not just discrete value, any number of outcomes. So that's the difference. So in our case study, because we are predicting the price, and the price can be any number, so it's a regression. So price can, if you are predicting whether the price is cheap or expensive, then it will be a classification, because here we are predicting as either it's a cheap or expensive. So we have discrete values, but we are not doing that. We are predicting the price in terms of dollars, which can be a continuous numeric value. Okay. So let's move to the case study. So we are going to predict the house sales in the King County in the USA. I think the King County is near Seattle, or it's a Seattle in the King County. But just my guess. I'm not fully aware of that, but it's just an example that we are going to predict the house sales of a county. So we have the data available, like the date on which house was sold, what was the price not for every house, but for some of the houses, and then what is the number of bedrooms, the number of bathrooms, and the square feet, the total number of floors, how many floors are there in the house. So these are all the features, like bedroom, bathroom. So based on those features, whether the house has a waterfront or not, and based on these features, we will predict what can be the price. Okay. So let's see how we predict. So for first, we import some libraries. Like one library is the Pandas, which we already discussed. The other is a Numpy. So Numpy and Pandas library, they are used for importing the data and performing some calculations or data transformation. And then these libraries, Matplotlib and Seaborn, so they are used for creating graphs or charts or for visualizing the data. Because sometimes a picture is worth 1,000 words. So by just looking at the picture, you can get an idea what the data represents or what the data structure is, right? So that's why we prepare some charts and graphs for the data using these two Matplotlib and Seaborn libraries. After that, we need to create machine learning models. So machine learning models, we use the library sklearn. So sklearn is the short abbreviation for the scikit-learn. So scikit-learn is basically, it has all of the machine learning model or machine learning algorithms available. So you can just import them, and you can create your own model and you can train them. Okay. So after we import the libraries, we then import the data. So the data can be in any format. Sometimes you will have the data available in the CSV file in your local computer, in your local desktop, or in your laptop, and the file can be a CSV file, or the file can be a text file, or the file can be a JSON, or sometimes you have to import it from the website. Okay. So here I'm importing the data from some website, as you see, starting from HTTPS, but it is in the CSV format. If you see, it is ending with .csv. Okay. So I'm using the pandas function read underscore CSV. So read underscore CSV, basically it reads the CSV file, and it will create a data frame structure for you. All right. So for example, here you see, so this is the data available. Okay. So if you see a number of bedrooms, number of bathrooms for each house, the price available for every house, the square feet, and the number of floors, how many floors we have, one or two. All right. So the total square feet of the house, like that. Okay. And because this data may have hundred thousands of records, so but if you only want to see the first 10 record, you can use this method head and you can specify 10. However, if you just want to see the first 5 records, you can give the value 5. And here, if you see, it is showing the value 5. Okay. So first let me import this data. Yeah. So now it's good. I have rerun the data. So if you see the price available for the first 5 rows, again the rows, they always start with the index 0. So 0, 1, 2, 3, 4. In total, there are 5 rows. And if you see here, it is showing that we have 22 columns. Okay. And then if you scroll down, you can check the data types of, so for every column, if here it is showing the data type. So most of the data types are integer or in float. So which is a good thing, because we have to convert every column to either the integer or the float, so that we can perform numerical computations. If it is but here if you see, it's a date, and the date is showing as an object, so which is not good. So for example, the date, it's not readable. If you see, so we should convert it to the proper date format. So for that, what we can do is we can uh, so here is a date function. So for the date, when we perform so this date, so if you see, now it is showing as a correct 13th of October to 2014. So now proper readable format. Okay. And also we also notice that the columns ID and sorry So these two columns, like unnamed, we don't know what the unnamed stand for. We have no idea. So if we don't know, we will remove it, because how will we know what information it represents? So we will remove that. Similarly, the ID column. ID is just like the sequence of the number 1, 2, 3, 4. It's so it won't give any valuable information. ID doesn't tell you how many bathrooms we have. ID doesn't tell how many bedrooms we have. So it doesn't represent any valuable information. So we will delete these two columns. And then using the drop method, we are deleting these two columns, and we are specifying the axis value. X is equal to 1. So axis can be either 0 or 1. So if you specify 0, it will try to remove the rows, but we want to remove the columns. So columns are like ID and unnamed. So after executing this, you know, after executing, if you see that the ID and unnamed columns have been removed and you don't see them anymore. So that's a good thing. So all these data operations that we perform, like converting it to a suitable format, like to date format, and removing the columns. So all these things are called data wrangling. So data wrangling is that you are playing with the data and you are trying to fix the data. If you don't perform the data wrangling and if you just pass the data as such, the machine learning algorithm, and so with that corrupt data or with the incorrect values or the values which do not have any mean or any meaning, sorry, which don't represent any, which don't give any valuable information, so those will be passed to the algorithm, machine learning algorithm, and the machine learning algorithm won't be able to give correct results. Okay, so the accuracy will be low. So we have to perform data wrangling. It's a must before you run any machine learning algorithm. And then we also see that we check for the missing values. So missing values, so it are represented as NaN. So NaN is a short abbreviation for not a number. So for example, if there's any missing value and it's not a number, then it will be represented as a NaN or NaN, not a number. Okay. So how do we check how many missing values are there? So if you run this info method, so in this info method, if you see all of the columns have 21,613 values. Okay, but in bedrooms we have only 21,600. So we have 13 rows which are missing, or 13 rows which have the missing values. Okay. Similarly, in bathrooms we have around 10 values missing. It's a 603 basically, not 613. So 10 values are missing. So you have two options, because the missing values uh, can give the missing values don't have any meaning. So machine learning algorithm will not be able to conclude like what values they represent, the missing values. So it's better either you can delete those missing values, like the rows or the columns with missing values, or you can insert or impute some values in those rows and columns where the values are missing. So, for example, um, I can take the average of a column. Okay, what's the average value? And I can just insert an average value in the missing block or the missing cell. Okay, so here we are doing the same thing. So I'm calculating the mean, how many average bedrooms are there for every house. Okay, so after calculating the mean, I am replacing that, the replace function. So whatever the missing values are there, I'm replacing with them with the mean value. Okay, after that, when we check for the missing value again, they are zero. So that means we don't have any missing values. All are, there are zero missing values. So that's a good thing. And then using graphs or charts, so if you see some pictures, some charts, so you can, so this is called the exploratory data analysis. So exploratory data analysis means that you can explore more things about the data. So for example, if I want to search how many houses have the waterfront, uh, and sorry, what's the price on average for the houses who have the waterfront and who don't have the waterfront? Okay. So for example, 0 means they don't have the waterfront, so they have less price. However, there are some houses showing value 1 have that waterfront, they have the high price on average. Okay. So we can see that any house with waterfront will have a higher price. Okay. So these, if you see these dots, so these are basically like outliers. So outlier basically it means they are like some exceptional cases. So for example, even though some house doesn't have waterfront, still it is expensive. And it may be expensive because even though it doesn't have waterfront, it may be expensive because it is in the downtown, or it's in the main city, or it is close to some market or supermarket or some other reason. So that can be the reason. So those are like exceptional cases. So we call them as outliers in the data science. Okay. Similarly, if you want to check how much correlation is there between the target variable price and any other feature. So to check the correlation, we can use the seaborn library method, RAG plot, and on x-axis we are giving that feature square feet, and the y-axis we are giving the price. So if you see, as the square feet increases, the price also increases. However, uh, there is not very high or strong correlation between square feet and the price. Okay. And so this is how you can check correlation of every feature with the price. So you can see which feature has the highest correlation with the price. Okay. And but you can also check numerically, for example, using that dot CORR method and correlation, and you can give the price method, sorry, the price target variable here. And with respect to price, you can check the correlation of all other features. So here the price, so correlation of price with the price will obviously be 1 because they are the same column. So correlation 1 means 100%. Okay. And so highest correlation, so we can ignore that price, and highest correlation is the square feet of living. Okay, so so basically the bigger the size of the house, square feet living, so big will be the price. Okay. And if you see the zip code, it is showing some kind of a minus value. So zip code doesn't basically represent anything, because uh, because most of the houses will have either the same zip code. And so that if you see, even though it's a negative, its value is close to 0, it's 0 0.0. Okay. And the other reason is that zip code is not scalable. For example, uh, for example, like let's say the bedrooms. So if a house has 1 bedroom, another house has 2 bedrooms, so that is scalable. So scalable means the value is getting doubled. But if it's a zip code, let's say uh, a zip code 90102, and then there's another zip code 90103. So that's not scalable. We can't say that zip code is getting doubled or zip code is increasing. No, they are just discrete values basically. So they are not continuous values. So it doesn't mean, so that's the reason it is at the bottom. And the same thing is with the longitude. So longitude, latitude, they don't have any meaning. Basically, I will say they are not scalable, just like zip code. So these values at the top, like square feet, living, and the bathrooms, and the square feet of the basement, the number of bedrooms. So these have some meanings. Okay. So let's move to the next, and so we can just so I will quickly jump on to the model development. Okay. So model development here, as you remember that we import the machine learning algorithm using the sklearn library. So sklearn is a short abbreviation for scikit-learn, and we are using the linear regression model. Okay. So linear regression, as the name suggests, uh, basically regression means moving further or moving continuously. Okay. And linear means there's a linear relationship between the variables, the target variables, and the and the other feature variables. Okay. So for example, let me show you the graph again. So this is a field, square feet above, and this is a target variable price. And you can see there's a line, a straight line. Basically, it shows the average of kind of a relation value or the relationship. So the angle of this line represents the average, the correlationship, correlation between the price and the square feet above, feet, these two columns or these two features. Basically, square feet is a feature and price is a target variable. Okay, so there's a kind of a linear relationship. So as the square feet is increasing, the price is also increasing slowly. As we see, the price is increasing as the square feet is increasing. So there's a linear relationship. So because there's a linear relationship, so we are using this model, linear regression. Okay. Unfortunately, we didn't have the test data available. So basically, the test data basically means where you want to test your model. Okay, so training model is that you train your model, you pass the data, you pass the labels, but you don't. But in the test data, we don't have the labels. Okay, so in this case, what we can do, we can split the data into training and the testing. Okay, so in this, as you see in this picture, we are randomly selecting these orange lines. Let's say this is just for the pictorial or visual representation, randomly selecting rows from the original data, and all those randomly selected records will show in the testing. And the other remaining 70% of the data, let's say 85% or 80% or 70% of the data, we mark it as testing. Sorry, the 30%, 15% or the 30% data, mark it as testing. And the remaining 70% of the data or 85% of the data is showing as training data. So we have split it based on the ratio. So like 70 to 30, or 80 to 20, or 85 to 15. So you can select the ratio whatever you like, whatever is comfortable to you. Uh, it's not some mandatory split that you have to split it in only in a 70-30 ratio, or you have to split only in the 85 to 15 ratio. No, in whatever the value you like, you can split. You can choose and you can split it on that on that ratio. And one more thing, you can so this is how we are splitting uh, the data. So for splitting, I'm using this train test split. So this is a train test split method, and I'm importing it from sklearn library. So here I'm giving the test size. Test size is of 0-15. So 15 means 15%. So that means I am saying uh, that 15% of the data will be marked as the test data, and the remaining 85% of the data will be the training data. Okay, and I also uh, make it clear that what is the x and what is the y. So x is basically, as I was showing in this graph, x is basically like on the x-axis and y is on the y-axis. Y is something we want to predict for the test data. Okay, and x is a something we already have both for training and both for testing data. But y, we only have it available only for the training data, but we want to predict for the test data. Okay, so here I'm on the x-axis I'm selecting only one feature or one variable, but for the model you select a combination of features in the x-axis. So these are the combination of features. Okay, and then you can select those combination features as the x, and the price is the target we want to predict is in the y. Okay, so now we have four output variables. So this represents the x-axis for the training data. This represents x-axis or the x features for the test data. This represents y-axis or the target variable for the training data. And this represents y variable or the y-axis data or the label data for the label for the test data. Okay. So I have given the naming as such, like X train, X test, Y train, Y test, so that it is easier for you to recall what these values present. So if you see, when I print the total number of records using the print function. So if you see, the testing records are around 3,000 and the training records are around 18,000. Okay, so basically they are split based on the ratio 85 to 15. Okay, so 85% records are like 18,000 and the 15% records are 33,000. So we will train the model on these training samples. After we train, then we will ask models to make the prediction on these test samples. Okay. So here, if you see, I am creating a model. So using these parentheses is creating an object. Okay. So like in a language, we create an object of a class. So you can see linear regression as a class, and you are creating an object, linear regression LR object out of the linear regression. Okay. And then we pass the data, both the training and the test data. Okay, and then when we pass that sorry, here we passing both the training data. My mistake. We are passing training data, and in this training data we have the features available on the x-axis. So which the features that that are available, and the y train is basically the feature on the y-axis, or which we want to predict. Okay, which we also call it as label. But for the training we will have this data available. Okay, training we will have this data available. So after using the fit method, the model is trained. So the model is trained on the training data using two set of variables. One set is the x-axis features, the other set is the y-axis features, or the label or the target variable. Okay, now uh, you know, uh, to predict, there's a method called predict, lr.predict. But here I'm not predicting. I am, instead of predicting, I am checking the score, how accurate my model is. Okay, before using predict, I first want to check what's the accuracy score. Okay, how accurate my model is. So in the test data, because the test data was uh, created out of the training data. So for this, we already have the label we want to predict. Okay, so we will compare the predicted values with the actual values. Okay, so whatever the predicted values we have, we predict based on the X test, and then we compare those predicted values with the Y test, and how matching results we get. So this is the accuracy, which is 0.6478, which means 64%, or which I will say 64.78 or 64.8%. So 64.8 is closer to the 65%. So our model's accuracy, our model is 65% accurate. So you will be wondering that this accuracy is very less, all right? Uh, Very less accuracy. We should be more accurate. So yes, you are right. We need to be more accurate. So that's the job of a data scientist will be. So as a data scientist, not only you will be working on importing the data, creating the model, and running the model, but your real task will be to continuously improve the accuracy. You have to continuously work to improve the accuracy. How can we improve the accuracy? So for example, how can we improve the accuracy? Let's see. So the one example can be one that we can scale these variables properly. So for example, if you see uh, the bathroom is increased from 1 to 2 or 1 to 3 or 2 to 3, so the scaling is very less compared to the scaling in this square feet. So there's huge difference between the 1000 180 value and the 2570 value. All right. Similarly, if you see some numbers are in like thousand, some numbers are like singular value 1, 2, and 3. So this doesn't help us. So machine learning algorithms uh, need a kind of a data which is scaled in proportion. So all of the features they should be scaled in proportion. So for example, uh, okay, let's say this 700 value 770, okay, it is getting uh triple here, let's say here around, let's say this is the, sorry, the double value. So let's say this is the third row uh, uh, is half of this fourth fifth row value. Okay, so we can represent it as a 1 770 and 1600 as a 2. So if we convert this into the multiple format, so it will be in the same proportion as you see in the bathroom, 1, 2, and 3. You know, the scaling will be similar for all of these features. So it will help machine learning algorithm in calculating this. So the another scaling what we can do, the scaling we can what we can do, we can calculate the standard deviation, and using the standard deviation for, let's say, for the scared living column, we can map which value is how many standard deviations away from the mean, whether it's one standard deviation or two standard deviation. So for that, for the scaling, what we can do, we have some scalar function. Okay, scalar, standard scalar. So using this standard scalar, I think we imported it long time back. Where we include? Yeah, here. So I think in the beginning of this case study, I imported the standard scalar. So this standard scalar, what it does, it scales the values on a similar scale. Okay. On a, so all the values will be, whether it's in bathroom or square feet, they will be mapped on a similar scale like 1, 2, or 3. Okay. So that it is easier for the machine learning algorithm uh, to to make the predictions. And then how we can improve the accuracy? We can also improve the accuracy using some different model. Like here I'm using the ridge model instead of linear regression, and here I'm using another machine learning model. So there are a lot of machine learning models, and what you can do, you can run each model on the data and you can see which gives a good result. So you can see with the GB, or with GB is short abbreviation for the gradient boost regressor. So it gives us 75.8% accuracy, which is closer to 76%. So you can see how we improved our accuracy from 65% to 75% by trying different machine learning algorithm, which is a gradient boost here, and using the scaling, and by scaling the data. So we were able to improve the accuracy. So there are a lot of ways you can continuously improve the accuracy. So you can at the final and in the final stage you will be able to improve the accuracy up to 85% or 90% or 95%. Okay, so it depends how good knowledge you have, how strong are your skill sets. Using that knowledge and skill sets, you can fix your input data, and you can scale them appropriately, and you can select only those features uh, which uh, which which represent the valuable information, and you can exclude the uh, rows or columns which don't uh, have any valuable information, which don't give any valuable information, like that. So there are a lot of methods, uh, but that you will be studying when you go to university or go to college. So there you will be learning all those tips and tricks, how to improve the accuracy of machine learning models. So here, if as you see that using machine learning models, I am able to correctly predict the house price of 75 percent houses. For the 75% of the cases, I mean our algorithm was able to correctly predict the price. All right, and I know it will be it may be a lot for you, for some of you, but you can go over the recording, and then you can see, you can learn again, and you can go over the recording again and again, and then you will be able to grasp the fundamentals or the basic concepts. Okay. uh, so one last thing I will also show you, it's the, for example, here we split the data on the ratio like 70 to 30% or 85 to 15%. So you can, so there may be a problem with this split, that there may be a bias. So for example, all the expensive houses may be in testing data, all the cheap houses may be in training data, or all the cheap, or all, or the like vice versa. All the expensive are in training and all the cheap houses in testing, or all the expensive in testing data and all the cheap houses in training data. So there may be a bias. So to remove that bias, we can try different combination of the split. So for example, in one case, we split the data like that, that we are taking only this portion of data in the testing, and then the second iteration, in the second run, we are taking this subset of the data as a testing data, and this iteration or this run, we are taking this data as a testing data. So we are trying different iterations, and we in each iteration we are selecting different subsets of the data as a test data, and using that you can take the mean or the average. you know so when we tried, uh, we didn't get that much improvement. So it was still, accuracy was still close to 65%. So basically, if there's not much improvement in the accuracy score, even after splitting the data in a multiple iterations, uh, you know, so it just means that there was no bias, like in the original split, like there was no bias. So for example, both cheap and expensive houses were in the training, and both cheap and expensive houses, they were available in testing. So there was not much bias. So because there was not much bias, so doing this all these repeated iterations with a different set of test data, it did not help us. So accuracy is still close to 65%. But what really helped us, when we scaled the data on a similar scale and using standard scalar function, and using the different machine learning algorithm, which is the gradient boosting, then we were able to improve the accuracy. Okay, so I think that's it from my side. So this case study was for like predicting house prices. So we predicted the price, and we we learned from the bedrooms, bathrooms, the square feet living, uh, from features, and using those features on the as a like on the x-axis, we our machine learning algorithm try to predict the price of that house, and we were able to see that the accuracy of our models was close to 75%. Right. So does anyone has any questions on this case study?
So I don't think there are any questions right now, but if you will have questions in the future, they can leave comments and ask them.
Yeah, sure. And Emma, you can email me whenever you get any questions from students, and I will be happy to answer them.
Okay, cool.
All
And
right.
yeah, okay. And then thank you again for coming back and finishing your workshop from yesterday.
Oh, you're welcome. It's my pleasure.
Okay, and then thank you for coming. That's it.
You're
And
welcome.
yeah.
All right. Thank you. Talk to you in future, hopefully.